In January of 1610, Galileo Galilei used his telescope to observe the planet Jupiter. What he found would ultimately change our understanding of the universe forever, and this tour is meant to explain why. 67 years before Galileo made the telescope he used to observe Jupiter, Nicholas Copernicus had proposed a new theory of the heavens that put the sun, not the Earth, at the center of a system of planets. By Galileo's time, many scientists thought Copernicus's ideas were useful for calculating the planets' positions, but they did not see a sun-centered solar system as physically realistic. Almost no one, and certainly not the leaders of the Roman Catholic Church, favored the idea that the sun and not the Earth was actually at the center of the system. Galileo was a religious man, and he did not set out to upset the Church when he went outside with his telescope on the 7th of January in 1610. What he saw would eventually remove the Earth from its historical place at the center of the universe. When Galileo published his findings in his famous book, The Starry Messenger, this is what he said about his observations.
On the 7th day of January in the present year 1610, at the first hour of night when I was viewing the heavenly bodies with a telescope, Jupiter presented itself to me. Beside the planet there were 3 starlets, small indeed but very bright. Though I believed them to be among the host of fixed stars, they roused my curiosity somewhat by appearing to lie in an exact straight line. There were 2 stars on the eastern side and 1 to the west. The most easterly star and the western one appeared larger than the other. I paid no attention to the distances between them and Jupiter, for at the outset I thought them to be fixed stars.
The next night, things got interesting.
Returning to the same investigation on January 8th, led by what, I do not know, I found a very different arrangement. The 3 starlets were now all to the west of Jupiter, closer together and at equal intervals from one another.
This arrangement interested Galileo not only because it was different than the previous night, but also because the points of light around Jupiter did not appear to move in exactly the same way as Jupiter did relative to the visible stars. Galileo loved to measure how the world changes with time. This is what led him to drop balls off the Leaning Tower of Pisa, and what led him to go back and observe Jupiter for many more nights and eventually years. Let's listen to some more of The Starry Messenger, but remember, Galileo didn't know yet that what he calls stars here were actually Jupiter's moons.
On the 10th of January, there were but 2 of them, both easterly, the third, as I supposed, being hidden behind Jupiter. There was no way in which such alterations could be attributed to Jupiter's motion, yet being certain that these were still the same stars I had observed. My perplexity was now transformed into amazement. I was sure that the apparent changes belonged not to Jupiter, but to the observed stars, and I resolved to pursue this investigation with greater care and attention.
Galileo kept on observing Jupiter every night he could for several weeks. On January 13th, a 4th point of light appeared around Jupiter. Galileo found that even though the objects around Jupiter he calls stars shifted their positions back and forth in a line, they never seemed to leave Jupiter's company. Somehow they belonged to Jupiter. After just a few nights of observations, he had decided,
beyond all question, that there existed stars wandering about Jupiter, as do Venus and Mercury about the sun, and this became plainer than daylight from observations on similar occasions which followed.
In his mind, Galileo imagined what happened in between the times of his observations. He saw that the movements of Jupiter's companions were consistent with a system of moons orbiting the planet viewed from the side. Galileo understood that if he could have observed Jupiter without interruption by daylight or poor weather, he would have seen this. Today we can see Galileo's correct picture from many perspectives, including a calculated view of Jupiter and its moons as seen from above. These modern images are taken from space. The most important perspective Galileo offered on Jupiter and its moons was actually about the Earth and its moon. In Galileo's day, people had difficulty understanding how the Earth could keep its moon in tow if it orbited the sun. Newton's theory of gravity was not published until 1687, 77 years after Galileo's first observations of Jupiter. But even without a detailed understanding of gravity, Galileo's results showed that a planet could, in fact, hold on to its moons as it traveled through the heavens. And so he wrote,
"But now we have not just one planet rotating about another, while both run through a greater orbit around the sun. Our eyes show us 4 stars, which wander about Jupiter as does the moon around the earth, while all together trace out a grand revolution about the sun in the space of 12 years.
Today, we know that Jupiter orbits the Sun in 12 years, the Earth in 1. Galileo's understanding of the workings of Jupiter's moons and many subsequent telescopic observations and calculations led him, in 1632, to publish the book Dialogues Concerning the Two Great World Systems. In the Dialogo, as it is known, he argues that the Copernican view of a moving Earth orbiting the Sun is not only a convenient calculational tool, but actually true. He argues, as we can see here, that the motion of the moons of Jupiter is just a miniature view of the motions of the planets around the Sun. It was for teaching this view, which included a moving Earth, that Galileo was put under house arrest by the Catholic Church in 1633. In 1992, Pope John Paul officially acknowledged the Church's error in Galileo's case.